broadcast is now starting. All attendees are in listen-only mode.
Good morning. Thank you for joining us today. Let me just double check my audio. Good. And then share my screen. Excellent. I really appreciate everyone joining us today on a Wednesday. I know we usually have these events on Thursdays. So my name is Ben Reese. I'll be your moderator today. Today's webinar is going to be part 2 of our Digital GD&T series, GD&T applications, which I'll discuss linear tolerancing, hole patterns, and GD&T frequently asked questions with Gary Bell, our GD&T ASME certified trainer. That's him coughing in the background.
Sorry about that, guys.
Yeah, we started just a minute late. I'm trying to fix a couple of audio issues. I'm going to be keeping our introduction short today so I can help assist some of our call-ins to fix their audio. See, check, make sure everything's okay here. Great. So if you're having audio issues, please use the raise hand button, which is on the side of your interface. You can see it right there. This is a bad image, but it's a raise hand button you can use. Please send in any questions you have throughout today's event. We have some time set aside at the end for question and answer. We also have a very short survey. It's only 3 questions after the event closes, which are basically, did you have any questions that weren't answered? What other topics would you like to see? And we are curious about some of your modeling methods, whether you're using point-based or feature-based modeling, just so we have a better understanding here internally. Let's see here, attendees. Get a couple others that are having some audio issues. Okay. Great. So today's part 2 of our GD&T webinar series 1. This is the 2018 series. In January, we'll be starting the second part of the series. So today's, as I mentioned, GD&T applications. Next week, we have our from GD&T to plant data, which is going to be 3DCS closed loop, hosted by Quality Digest. So that will be hosted through a third party. All of you that are part of our DCS All Access group will be registered this afternoon for that webinar. Otherwise, look in the follow-up email for a link to register if you're interested. Part 4 will be supplier quality for suppliers. That's going to focus on tools to support tolerance negotiation and internal quality for automotive, aerospace, medical device for manufacturing suppliers. That'll be on November 29th. And then part 5 in December will be iterative design and logic using iteration move and mechanical moves in your models. All right, so today's agenda. Just having some slight international issues. So today's agenda will begin with linear dimensioning, and we'll be discussing in general dimensioning hole combinations, understanding hole tolerances, mixing GD&T and other dimensioning techniques, and tips for using GD&T and 3DCS. We'll be going through these using questions from our previous webinars that Gary Bell will be covering. Today's software. So we do have 5, 6 versions of 3DCS now. So today we will be using 3DCS integrated in CATIA v5 as it's our most common platform. And because due to limited time, we will only be able to show it in one platform today. So I apologize to our other users. Our interface should be the same for all of the different versions we have, as we will be using primarily 3DCS rather than the CAD-specific tools. As I mentioned, today's presenter is Gary Bell, Senior Variation Analyst here at DCS and ASME Certified GD&T Trainer. Gary Bell is our go-to when it comes to GD&T here at DCS, and he's the one that runs and organizes our GD&T training classes. He's also paramount to our sales activities and to assisting new customers with 3DCS questions and modeling. All right, Gary, well, at this time I'm going to pass it over to you. If you'd like to show your screen.
All right. Can you guys see my screen? You can. How do I minimize this with that window?
Oh, you have to use see this little arrow in the corner, this little orange arrow?
Oh, there we go. Thank you. Thank you. Thank you. Okay, so we had 3 webinars talking about creating GD&T in the CAD systems, Creo, NX, and CATIA. From that, we requested questions that anybody had, and we documented those questions, and then I'm not going to, state the question in any specific order. I just use those questions to make a list of things I want to show you. So I'm going to start out. You can see I have a model. I basically mixed a bracket model with, our feature-based modeling, just because, it's easy. And if we look here, you can see that in my rocker, I have one feature, I have a bunch of DCS points, and there's no tolerance on it. So to talk about linear dimensioning, I'm going to, by the way, do all of this with our new GD&T tolerancing function. So I'll pick the part. And you can see, you have all of your GD&T callouts here. I'm just going to add size. And I'm going to pick this feature and this feature. And we will make it 1 millimeter so you can see it, and just say OK. One of the things I want to point out is what's really nice about the new dialog box is I can change this to any of the GD&T that I want while I'm in the middle after I've picked my features. So the dialog box is very thorough as far as being able to stay in one location and doing everything that you would like. If I say OK, now you can see in my tree I have a GD&T folder and I have a linear tolerance. Oh, by the way, I failed to tell you that notice how it says 1 millimeter GTOL1. If you go into your preferences, in case you're not aware of it, we do have alias display. And inside alias display, you can customize what you want it to display here. And so you can see I activated GD&T, and if I hit this customize button, we are currently showing the range, which is the GR, and the name. And I'm letting the software just keep the default name, and so you can see it just called it GTOL1. But because we have the symbols, you can now, quickly and easily see what type of tolerance it is. So now if I zoom in here and I hit deviate, oops, sorry. When you're adding the DCS GD&T, you have to do one nominal build. And so now you can see that is deviating for size within that plus or minus tolerance that I applied. From there, I'm going to now put a linear tolerance from here to here. So now instead of a size tolerance, I'm going to come down here and say dimensioning location. And you'll see the symbol changed. It actually is utilizing the origin symbol. And I'm going to say add and pick that surface and that surface. Now, when you use the origin symbol, the first feature you picked is going to default to the origin. You can modify that origin somewhere. Oh, thank you. With this pull down, if you want to switch which face is going to be your origin. I'm not going to do that at the moment. And I'm going to make this 5 millimeters so that we can really see something happen. Okay. And now you can see the symbol changed. And this is 5 millimeter tolerance. Okay. Again, do a nominal build. And so you can see this is moving 5 millimeters. and this has got the size tolerance of 1 millimeter, and this surface is tracking this surface. Okay, so what I want to do is I want to show you some of the pitfalls that can happen if I come into this tolerance and I change it to size and say apply. Now when I do a nominal build, you can see that it's going to pop up and say, hey, we can't do this because I can't have a size tolerance between these two faces and a size tolerance between these two faces. There's not enough information for us to understand how you want this to deviate. Okay, so you can do chain dimensioning, even though I don't approve of it. If you want, you can do chain dimensioning, and you can do origin from here to here, here to here, and here to here. And you can dimension, everything that you want with linear dimensioning. I'm going to change this back to this, and we should be, oh, that's not, yeah. Okay, so I want to jump over, because one of the questions was, what about linear dimensioning on holes? So I came over here, and now I'll just say tolerance, pick this part, and first I'm going to just say size, just to show you that if I add size, and I pick both features, and again, I want everybody to see everything, so I'll say 1 millimeter. Now in my bracket, I actually have size, and so let me modify this real quick so it's easy to see. Okay, so now you can see I wrote one size tolerance and I picked multiple features and they're deviating randomly independent for size. If I wanted them to deviate together for size, I could go into my options and I could say group all features. I'm not going to do that in this example, but I will do it later on when I put flatness on non-coplanar surfaces. So now, if I come in here and I add dimension location, as I mentioned, the first feature picked is going to be the origin. So I'm going to say I want to put a dimension between that hole and this hole. And again, I want everybody to see stuff, so I'm going to say 5 millimeters. Okay. So now you can see they're changing in size. This one is the origin, and this is moving linearly back and forth within a range of 5 millimeters. Continuing on that, I will add another dimension location, but this time I'm going to tolerance those holes from this edge. Uh-oh, never mind. So I'll pick that, pick that, pick that, and make this 10. So now you'll see, notice how these are moving together as a 10, even though I wrote a single tolerance, unlike the size that was moving independent. If you want this to move up and down 10 independent of this one, you would have to put 2 linear dimensions, one from this surface to that hole, and this surface up to that hole. Okay, so now I'm going to come back to this bracket here, and I'm going to put some datums on this so that we can start talking about some more GD&Ts. Oops. So now I'm just going to leave it set to datum. I'm going to call this A. Sorry, call this A. Add that feature. Okay. Okay. Add another datum. Pick that surface. Okay. Okay. Add one more datum. Okay. Now you can see I have datums A, B, and C, but I want to, put some pre-qualifiers on it, and I want to tolerance something back to a datum reference frame. So I can go into any one of these, and I can click on the datum reference frame tab, and you can see these are the features that I have. So I want a datum reference frame that is A and B, so I will add that. And I want another datum reference frame that's full blown. Delete A, B, and C. Now I have two datum reference frames. So with that, I'm going to go ahead and I'm in my rocker, right? Yeah. So now I'm going to add a perpendicularity tolerance. On this feature here. 1 millimeter. It's a surface, so I don't have a modifier, and I want to go back to just A and B. Okay. Okay. So now you can see this surface is tipping and rocking within its perpendicularity tolerance back to A and B. This surface is deviating with its linear tolerance back to this surface, which is deviating due to a size tolerance on this surface. If I continue on and I say, I want to add a profile tolerance to this surface, back to A, B, and C, 1 millimeter. Now this is where if I do a nominal build, separate, and deviate, you can see that this is moving a lot more than 1 millimeter. This I'm hoping we will ultimately add a validation error that tells you that this surface is double toleranced. It's toleranced 1 millimeter to A, B, and C, and it's toleranced 5 millimeters back to this surface. So you can't do that, and if we can catch it, we'll warn you. What I do want to do, though, is I want to talk about common zone, and I'm going to put a flatness tolerance on these bottom two surfaces. And let's say okay. Now flatness we know is a refinement of location and orientation, and you can see those surfaces are deviating for its form control. Because we are deviating from nominal, it's essentially treating it like it's a common zone. If you apply flatness to two offset surfaces and you define it as a common zone. Now, if I continue on, if I continue on and I add a profile to that surface, and I pick both of those faces again, and I'm going to make this 10 millimeters. Back to A, B, and C. Okay, so now if you catch it, you can see those are changing in form, but they're definitely not treated as common zone. Okay, so you have to, and this is when I'm training people, with the software, I always say, hey, make your tolerances big, deviate it so that you can see what is it doing. This is an example where if I want to treat that form control as common zone and I have this profile tolerance, I would have to go into my options, and this is where I would want to say group all features for the profile tolerance. Now, when I deviate it, you can see it's still moving within the 10 millimeter tolerance zone, but it's taking both faces with them and they're deviating within that 1 millimeter form zone. Now, one of the questions that came up was, what happens if I do all point-based modeling? So if you remember at the beginning of this, I pointed out that my rocker has all coordinate points. So if you did your model and you have coordinate points, they obviously are not linked to any features. So, the first thing that you can do easily would be to project these points onto that surface. So you would do that with your feature point creation dialog box. Select your points. Select your feature. Move points and project it on feature. If you don't click move points, you'll create another set of points that will be feature points linked to the surface and coordinate points at the same location. So now you can see those points converted into feature points, and I still have coordinate points over here. Now when I deviate, you can see those points are moving with the surface, both form and location. These points are still coordinate points and they are not linked to the surface. However, you don't have to link them to the surface if you don't want to. I'm going to go into this profile tolerance, and under my feature list here, you can see it's got those two surfaces. I'm just going to go ahead and say add, and I'm going to pick these points manually. Now you can see my feature list has got features and points. I'll say OK. Now you can see those points are moving with that surface. So, as I always tell everybody, that our software is point-based and feature-based. This is my example of trying to show you. So when I do my modeling, I try to stay all feature-based first. If I can't simulate what I want, then I will go to feature points. If I still can't simulate what I want, then I will go to coordinate points. So with that, I'm going to move over to this part here, because the question was, how do you handle pattern of holes defined as a datum? So with this part, again, if I go into, I change the mesh color so there's an offset, so it always kind of confuses me with the tree, because the parts up here is green in the DCS tree, and you can see there's no GD&T. So real quickly, I'm going to add some GD&T on here. I did say datum, right? Okay, I wasn't sure, so I had to back up. Datum A, oh. Datum A, add, pick that surface, okay. Okay. Size, add. We'll leave it 0.2. Just to check real quick, if I zoom in here and say deviate, okay, I can see the size is moving. I created points on here because sometimes that helps you see stuff. So I'll come in here and I'm going to add a position tolerance, add. And you'll see, here I'm adding a position tolerance on a round feature. So I want to set it to diametrical. I'm going to set this to 2 millimeters. I have no datum reference frame. Okay, I really only want to, because I'm going to make that my datum. So I have to go to my datum reference frame. And I need to make a datum reference frame A. Apply. Now I can come back here, and now I have datum A, reference frame 2 millimeters, say okay, okay, okay. And then I can continue on. Actually, I should be able to. Datum, add. Datum B. Okay, so the issue was, how is the parts constrained when you have a hole pattern as a datum? So we know if I, make these two holes datum B, then that's going to control my left and right and my, it's going to control my Y variation and my X variation when it's assembled. The constraint system is taken care of by the moves. So all I did was tolerance this part. It should deviate, okay? And so you can see it's got the hole position tolerances, then that pattern of holes is datum B, and the bottom surface is datum A. How that is taken care of is in the moves. If you look down here, I added 2 moves. My original move is a feature move, and it's using this hole as its 4-way locator and this hole as its 2-way locator. And if I go into the measurements, I'm measuring whether or not this hole is crashing through that pin. So if I only have the feature move, which is primary, secondary, and tertiary, or if I'm using our step plane or 6-plane move, I don't get to use both holes as a locator. So when I do a nominal build and I run an analysis, you can see that measurement, checking this pin, is crashing a lot, okay? But that's because the move is not using both pins to locate this part as a hole pattern constraining that part. For that to happen, we have to add the pattern move. And the pattern move is picking both pins in both holes. If I activate the pattern move, and run another analysis. Now you can see that that circle interference measure, which was right here, is good. It's either net or it's got a clearance. If you tolerance your parts badly and it can't solve, so I'm going to come into the rocker. Come on. Rocker. Oh no, it's the lifter. I'm sorry. Where's my lifter?
It's the lift to the green one at the top.
Thank you. Yeah, so I'm going to go into this position tolerance, and I'm going to change it. Notice now how we've combined this. This is a little sidebar. I wrote two separate callouts. I put a size tolerance on these holes, and then I put a position tolerance on those holes. But now if I go into either one of these, it's showing me that, hey, these two features have got a size tolerance on it of 0.2 and a position tolerance on it of 2. And you can edit, either one of these. I forget how to make that arrow go up there. On the very top. Oh, up here. Okay. Thank you. So you can see it's showing us everything that's applied to these features. And depending on what I want to edit, I can hit this pull down and change where this arrow is pointing to. I want to just change this to 3 millimeters. Okay. Get a visual so you can see those are moving around a little bit more now. And then when I build this and run an analysis, now you can see it's still built, but now it could only build 1,982. So based on how we toleranced our parts and how we're trying to constrain it, meaning locating the lifter with the whole pattern, it can't solve it. So now you would have to address this by either increasing the clearance holes on increasing the holes on your lifter, decreasing the position tolerance on your lifter, decreasing the pin size on your base, whatever you need to do. Okay, so if we look at, let me minimize some of my tree here. If we look at the rocker, you can see I have all kinds of GD&T on here now. I got a linear size tolerance, I got a coordinate size, origin size tolerance, datum A, datum B, datum C, perpendicular, profile, flatness, and location on those surfaces. I'm going to, just so that I can make a mistake, I'm going to also add parallelism. Add to this top surface. Oh, that top surface was datum B, wasn't it? Sorry, I don't want to do that. Let's add this bottom surface. So I got parallelism. I'm going to say 3 millimeters so I can see something. And I'm just going to say, okay. Okay. So you can see that surface is deviating for parallelism. However, I did not define it back to any datums, and if you don't do that, then just like our original software, we are deviating it from nominal, and it's not related back to a datum reference frame. So when you're all done with tolerancing your parts, actually when you're all done writing moves, tolerancing, and measurements, obviously the first thing you want to do is hit validate. And you can see that I have an, rigid body move uses a non-point. That's an error I didn't know I made. I'll have to check on that one. Wasn't supposed to be any errors in this model. But the other thing that you can do is you can come up here and you can run your tolerance wizard. This is, a lot of people don't know about this. It's a very nice function. I'm starting to use it more and more, and I'm liking it more and more. But if I run my tolerance wizard, it's going to give you this box here. And if we go to, let's go to the rocker and expand my tolerances. And you can see it's telling me that it's, okay with the tolerances, but this tolerance here is red. And it's, if you look at the color coding down here, GD&T is invalid. It's got 3 millimeters, GTOL 17. It's parallelism, invalid syntax, material condition, invalid material. Oh, I might have screwed that up too. And it requires a DRF. That's really interesting. I could go in and fix that material condition. It probably has one and it's not supposed to. And also, it's got a, okay. So I purposely made it wrong so that you could see what the syntax, what the tolerance wizard would tell you. So I don't care if it's wrong. That was my goal. And also, if you see, up here under the feature list, you can see these feature lists are all listed as yellow. And that's because it's got tolerances in them, but it's not used in a move or a measure. So the idea is when you think you're done with your model, and I tell everybody when I'm training them that if it's not a datum and it's used in a move or a measure, it needs to be toleranced. So this helps you take a glance at all the features in your model. And if I have a feature that's in my model that's not being used, it's going to show you up here. If I have some GD&T that's wrong, it's going to show you down here. And then, we have validations for moves and measures as well. I just wanted to show you quickly that this function exists and that you can use it to help validate your GD&T. Maybe we'll have a separate webinar to just talk about this GD&T checker.
Good.
I think that's what I got, guys.
We're about 45 minutes past the hour, so we have some time for some Q&A. So if you have any questions you'd like to see, I've got Gary Bell here available for you. So if you want to see something about the pattern or linear dimensioning or a clarification, this would be a good time to send those questions in and let us know.
Go
I
ahead.
have a question. As a non-GD&T knowledgeable, I don't know GD&T as well as Gary, but when you were creating that flatness tolerance and you were showing us how when you created a profile, you put a profile of A, B, and C on it. would with the common zone.
Right.
The difference with a profile of no datums, would it work the same way as the common zone?
Yes. Profile with no datums would act like flatness on those two surfaces because they are flat surfaces. Now you can't put flatness on a curved surface, which is why you have profile to no datums, which would control form on a curved surface. But yes, on this particular part, I could have replaced the flatness with profile to no datums. Good question.
Thank you.
Do you want me to do it?
Another thing I wanted to point out too, the difference between how a CAD system creates or requires a how to define a feature control frame, and whereas Gary showed us that you can go ahead and define your datums and then have a profile, let's say a perpendicularity on datum B, which would turn that datum B, I'm sorry, the perpendicularity is the refinement?
Yeah, perpendicularity should be a refinement to profile.
Okay.
It-
So within a CAD system, the way that it works is that you have to define datum A and then define perpendicularity back to A. Then you have to go ahead and create your datum B on that perpendicularity. So it's just something that I realized is that you don't are not necessarily required to follow that same order.
We are not we're not required to follow the order, but that's why when you add your GD&T, you are required to hit a nominal build and separate.
And that
because that's where we look at all the GD&T and we figured out that, oh, you called it datum B and then you added perpendicularity. So we treat it correctly. That's why you have to do a nominal build first. So we scan through everything.
Gary, can you open your About just to show what version you're using?
Yes.
So you're using the latest version, 7.5.1.
F. Yeah,
So-
all this GD&T doesn't exist in 7501.
Gotcha. So it's coming out.
It's going to be in 7.6, right, Dave Johnson?
That's correct.
Great.
And the other thing that's key to note is you don't, because we did add the whole capability of using GD&T and datum reference frames. You saw me put perpendicularity on a surface with no datum reference frames, and it's still tipped and rocked. It's just tipping and rocking from nominal. It has no connection to, back to a surface that could have a tolerance. And we give you an error saying you shouldn't do that, but we allow you, for instance, I can say profile, or I can, pick this part, and I'll just do exactly what Jason said. I'll say profile of the surface, add, pick that face, okay, 1 millimeter, and just quit here, okay, deviate. So you can see that's moving even though there's no datums. And it's moving for form only. Now what's interesting is I would like to, this is in the base. Let's go back to my tolerance wizard and go into the base. Okay, so it doesn't have a problem because you can have profile to no datums.
Sweet.
So, yeah, okay. It doesn't have a problem.
When you have that DLL open,
Oh, yeah, the one I just closed?
yes, that one.
Yeah, that one.
Can you double click on one of the tolerances to open it?
Yes.
So, for example, if you see one is that what you just did?
No. Let's go. Let's go to the which one? I want to go to the lifter, right? That's the one I did all my tolerances on.
Yeah.
Oh no, I'm sorry. The rocker. The rocker is the one I did all the tolerances on. That's got this bad tolerance. You okay?
Oh, okay.
Okay. Yeah. So if you see something wrong in here, just like if you see something in our validation, when you hit validation, you get errors. You can double click on it, and it will go to where the error is. Same thing here. You can double click on this, and it will jump over to the tolerance where the error is, so that you can fix it.
Great, thank you.
Sorry about that. We were just going over a couple of questions. All right. All right, Dave, do you want to field one for me?
Sure, which one?
It says GD&T to be displayed with the features.
That's a good one.
Looks good. How will old models GD&T be handled in open and new version? Old model GD&T.
So I have a model where I created GD&T using, tolerances or,
You mean using like the feature tolerance?
or using extracted GD&T.
Oh, yeah, extracted here. That's a good question.
You guys on?
Yeah, we're on.
Yeah, so the old tolerances, linear tolerance, feature tolerance, they're going to still be in. They'll still be in here. In other words, if you did a tolerance, so now you can see there's two buttons here. I'll click this part, and I'll add feature tolerance, add, pick that surface, close. Okay. So you're going to end up, you're going to see your conventional tolerancing for old models and any kind of GD&T. If you extracted the GD&T, it's going to come in and go into our dialog boxes, like you see here when I double click on this one. And to show it to you, this is a big secret. This part does have embedded GD&T. If I go into my rocker, you can see it's got GD&T here, which I have hidden because I wanted to talk about just our GD&T. And you're going to force me to show you something that we still have to address. But if I come over here and I say update GD&T, pick this part, I do not. If I say replace, it's going to delete all of my GD&T and use just the CATIA FTNA. I learned that about 10 minutes ago. No, before this thing started. But if I uncheck that and pick this part, now you can see I have GD&T that was extracted from the part, and I have DCS GD&T also. And one of the things you can tell is when you look at your list, that little teeny tiny thing here. What? This is telling me that this GD&T came from extraction, plus it's showing you that it's linked. So when you extract your GD&T, you're going to have a plus sign here because this is linked to the FTNA up in the part. And the DCS GD&T will not have a plus sign because it's not linked to anything in the CATIA.
All right.
And then this is going to look exactly the same. There's the dialog box.
All right, I'm going to field that one you just answered. Is that okay, Dave?
Sure.
All right. Is there still a setting to use plus or minus tolerancing method? Look right here.
So that's on the options page. The
Oh.
options tab.
Inside here?
Oh,
Yeah.
it would be.
Yeah, so range and offset.
Oh.
Yeah.
Yeah, you want me to change it?
Doesn't matter. Sure. It's just a question.
So,
You know.
yeah, there is a setting. You can still go and change your preferences to plus or minus, and it will change it inside the options tab.
All right, so it's still available here. It's just in the options.
Yeah.
Okay, good. All right, we're just taking a look to see if there's a couple other questions we might want to field right now.
You put the tolerance wizard again.
Yeah. Can you open the tolerance wizard again? Sure. I like the tolerance wizard.
So, one of the things I also wanted to point out is on the very top of the dialog, you have hide tolerance features, hide not used features.
Right.
So when you uncheck those, you can see everything, all the features that you have selected that are not toleranced. They'll actually show either a white square or no square in the list. So if there's any features that are, yeah. So it kind of is a filter to reduce your tree list and only show your tolerances that are.
Oh, I see. Yeah. So, like I said, I'd like to have a separate webinar just studying the tolerance wizard.
Righto.
Because I've just started using it myself. Can a pattern of holes be primary data features in a DRF? Are we live?
Yeah, we're live. I'm going to circle back to that one.
Well, no, I would say, can you show me an example? Because I cannot.
All right, let's take that one off.
I can't visualize a pattern of holes as a primary because the surface the holes are in part's going to net to, which is probably going to be my master main surface. So I'd have to see an example.
The tolerance wizard, that's available? That's been available for a while, hasn't it?
Yes,
Yeah.
it's actually available in 751.
Okay.
I'm not sure. Have we been making any modifications to it, Dave?
Yeah, I think the GD&T wizard was
Added.
GD&T checker was added since then.
Okay, so yeah, so the capability of it checking your GD&T is going to just be in 7.6. But the tolerance wizard is, I mean, the key with the tolerance wizard is, do you have a surface used in a move that's not toleranced? We need to flag it so that you know, hey, you better tolerance it. But yeah, it is available in 750 or 7501.
Can you just review real quick that opening a part with PMI or importing the part GD&T? So remember that since we're in CATIA today, the PMI or the embedded CAD GD&T is called FT&A.
Right.
But in Creo or NX, PMI, and in our previous recordings from the last session, we do show extracting the PMI from Creo or from NX.
Yeah, so I'll go ahead and you can see that I like just sticking with a part. So I'm going to go ahead and delete all of my GD&T, and I'm even going to delete all my features. So now you can see I have just coordinate points on this part, and I'm going to come up here and I'm going to unhide the GD&T. So this is the FT&A, or functional tolerance annotation, that's embedded into the CATIA part. If you have your tolerances written inside your 3D part, either PMI in Creo, in NX, FT&A in CATIA, then you come over here and you hit Update GD&T, pick your part, and now you can see it meshed all the features that were being used in the part. And if I come down into my rocker, I now have, let me get out of that. I have my datums, not a whole lot of GD&T, and one tolerance on this surface, and then it's going to deviate. Of course, my points aren't moving because they're coordinate points. I'd have to reconnect them to the surface.
Yeah, they have to be attached to the features.
I mean, is that the review you were looking for?
Correct.
Okay. That's an easy review. Hit the button.
Yeah, it's all the same in the 3DCS, NX, Creo,
Right.
5, 3D Experience.
So now once it's extracted, you can see, like I mentioned, it comes in with a plus sign. It's got that symbol on it that says that this was pulled from the CAD system. But if I double click it, it's our dialog box, and I can change this to 10. Okay.
Another nice value about extracting it from the CAD system is you can push it back to the CAD system, right?
Yes. So here you can see I changed the tolerance to 10, and I can come in here and say, yes, that's the tolerance I want. Apply and push GD&T. And now you can see this turn to 10. Oh, yeah. They can see it. You
They
can't
can see it. Yeah,
Yeah.
sorry. Let me get that out of
Right.
Right there.
Yeah, so we have a pull-push capability in CATIA. We can pull the FT&A. We can make changes to the numbers. We can push it back. In NX, we can pull the FT&A. We can pull the PMI. We can make changes. We cannot yet push it back. Correct, Dave?
No, you can
Oh,
we can push it
I-
back. The only thing,
I stand corrected. You can push it back. Can you push it back in Creo?
All three.
Well, the
Pull in,
developers
push
are
out.
cruising right along over my knowledge.
The only thing that you can pull in and push back is the range.
Right.
The range, defined offset, and then project the tolerance zone, and I think the modifier.
You can do that for all three
Yes.
platforms.
Mhm.
Oh. Wow, guys, I'm excited. I didn't know that.
Great. Okay, well, actually at the top of the hour now, so I appreciate all the questions. We had a couple of short silences as we had quite a few questions come in, and Dave, myself, and Gary have all been trying to tackle which ones we can show live and which ones we need a little bit more feedback on. So we've been trying to do as many as we can here. So we're 2 minutes past the hour. I'm closing the webinar down now. If you have any additional questions that were not answered today that you think of, please add those into the survey after the webinar today. And we'll follow up with you shortly. You'll receive the email tomorrow with a recorded session, and I'll throw in the recorded sessions from the previous part as well. So you'll see our creating CAD and NX, Creo, and CATIA along with those models. I believe those are still available through our file share. If you have any additional questions that come up later, feel free to reply to that email directly to myself, and I'll connect you with our support team. Remember, we do have the community available for you for questions and answers. If you've got some questions you'd like to share or examples you'd like to share, we'd be happy to work with you on those. So once again, thank you so much. I appreciate you all coming, especially on a Wednesday. I believe this is probably our first Wednesday webinar we've had. So thank you so much for taking the time out of your day. Great.
Done?
All done.
Look at that. I got a customer waiting for me now.
Yeah.